Okay, 5.7 example 13 says to solve from 0 to 2 pi, so we're back in radians. Sine of x over 3 is equal to 1/2. Again, this is considered a multiple angle, so multiple answers just means we're going to use that table. Okay, so remember the sine is positive in quadrants 1 and 2, so we're going to have a quadrant 1 answer, and we're going to have a quadrant 2 answer. Now, instead of x equals, we know in the place of it is x over 3. And so where in quadrant 1 is sine 1/2? And so that should be at pi over 6. And then we're going to put plus 2 pi n because it's a multiple angle. And where in quadrant 2 is sine equal to 1/2? So we're going to put x over 3 equals, and sine is equal to positive 1/2 in quadrant 2 at 5 pi over 6. And then we're going to put plus 2 pi n. Now, because it's x over 3, the only way to get rid of the 3 is to multiply it. So every term gets multiplied by 3. And so we get x is equal to pi over 2 plus 6 pi n. Over here we're going to multiply every term by 3. And so we get x is equal to 5 pi over 2 plus 6 pi n. Well, think about this, guys. Plus 6 pi n. If I go to add, if n is a 1, I'm adding 6 pi. That's going to be definitely outside of 0 and 2 pi. Right? If I am subtracting, if I put in a negative 1, that's going to be subtracting 6 pi, which means I'm going to be way too small, okay? So you might be able to think this one through without actually making your table, but to be consistent, I'm going to make my table. Alright, so there's my n column. I have pi over 2 plus 6 pi n. And I have, 5 pi over 2 plus 6 pi n. So I'm going to start out with n is negative 1. And so I got pi over 2 minus 6 pi. Geez, that's what? 1 pi over 2 minus 12 pi over 2 is negative 11 pi over 2. That's not between 0 and 2 pi. So I'm going to do the same thing over here. I'm going to plug in n is a negative 1. And so I got 5 pi over 2 minus 6 pi. Remember 6 pi, you write it out over here, is the same as 12 pi over 2, okay? So 5 pi over 2 minus 12 pi over 2 is a negative 7 pi over 2. That's not between 0 and 2 pi. So I'm going to try when n is 0. So pi over 2 plus 6 pi times 0, which is pi over 2 plus 0, which is pi over 2, which is between 0 and 2 pi. Then we have 5 pi over 2 plus 6 pi times 0. So 5 pi over 2 plus 0 is 5 pi over 2, but wait, 5 over 2 is 2.5, right? So this is the same thing as saying 2.5 pi. That's not between 0 and 2 pi either. So that's too big. So I had one up here that's too small, one that's too big. I'm done in this column, okay? I don't have to work anymore. There's no answers coming out of it. First one was too small, second one's too big. I'm done in that column. But I still have that first column to work because I had it too small, but I haven't had it too big yet. So let's keep going in it. So I'm going to choose when n is 1. So pi over 2 plus 6 pi times 1. So pi over 2 plus 6 pi, which is 13 pi over 2, which is, what, 6.5 pi? That's not between 0 and 2 pi. That's too big. So I'm done in that column as well now. So when I look here, I've really only got one answer. And so the answer for this problem is pi over 2.